Hi, welcome back. We're going to be looking now at when limits fail to exist. So last time we were looking at limits that existed. We're going to look at ones that fail to exist. So the first example that we're going to be looking at, this is example 3 from the book. It's when the behaviors differ from the right-hand side and from the left-hand side, similar to the ones that you guys did in the homework. So this is our example. It is the limit of, as x approaches 0 of, oh man, I gave you guys the answer already. So it doesn't exist. I will let you guys know it doesn't exist, but let's see why. So it says, what happens when x is equal to 0? Well, this is 0 over 0, which is indeterminate, but that doesn't mean that it doesn't necessarily exist. So that means that we need to do some more work. So we're going to see, okay, what happens when x gets close to 0? So what happens when x gets close to 0? Because example 1, it was indeterminate, but the limit did exist. So let's see. So graphically, let's think about this for a second, though, before I show you guys the graph. Let's think about what this graph does. So this graph, it takes this function right here. What it does is it takes an x value. So if your x value is, say, -5. So let's look at, I'm going to work over here. So let's look at x equals -5. If you plugged a -5 into here, it would be absolute value of -5 over -5. The absolute value gives you a positive value, which would be 5 over -5, which would be -1. So see how we're always going to get this number over itself? A number over itself is 1. But the numerator is always going to be positive. So this is going to be a positive over a positive or a positive over a negative. So it's either -1 if our x value is a negative. But if we have x is equal to 5, for instance, we would have 5, absolute value of 5 over 5, which is 5 over 5, which is a positive 1. So it's either going to be -1 if our x is negative, or it's going to be a positive 1 if our x is positive. So graphically, it's going to look a little something like this. So we know at 0 it's indeterminate. There's no value there, so it's going to be open circles. But when it's positive, so when our x values are positive to the right, our y values are going to be +1. A number over itself, a positive number over a positive number. These over that, yes. And these numbers are always going to be -1, a positive number over a negative. So remember, a positive over a negative. And the numbers are the same, so it's 1. So this is what it looks like. So if we look at it, we approach both of them from the right and from the left. First of all, there's discontinuity. There's a huge jump right here. So there is discontinuity again. So there's discontinuity. And also, there's a huge jump, which is different than the ones that we looked at before. So let's look again. So remember, we said any negative number is always going to give us a -1. Any positive number is always going to give us a +1. So I have the workout over here. So just to convince yourselves, if I put a -0.0001 in print or in the absolute value signs over -0.0001, this absolute value gives us a positive value over a negative value. This gives us -1. This is going to be the absolute value of 0.0001 over positive 0.0001. It's positive over positive. The numbers are the same, so it's going to give us a +1. So these two functions, they approach two separate numbers. They're different. So there are two different numbers f of x approaches, not one. So the definition for a limit requires us to have 1 point, not 2. So this one, because there are two numbers, not one, the limit does not exist. Okay, so let's look at another example. So another example, example 4. Again, this is one that doesn't exist, but this is with unbound behavior. I'm going to show you guys why it doesn't exist. So what happens when x is equal to 0? Well, here, when we plug in 0 into our function, we get 1 over 0 squared, which is 0, which is undefined. So doesn't necessarily use, well, let's see what happens. So it's undefined, so let's see what happens when x is close to 0. So let's look at it graphically and numerically. Graphically, the graph of 1 over x squared looks something like this. It's kind of like 1 over x, so 1 over x looks like so. So remember 1 over x looks like this. But since it's x squared, this means that all of our values, all of our y values are going to be positive. So these y values are negative. They're below the x-axis. So they're going to be positive. It looks slightly different. It's a little bit closer to the axes as well, but this is a rough sketch of it. But looking at this, as we go from the right hand and from the left hand side, and as we look as x gets closer and closer to 0, these numbers seem to be getting just larger and larger and larger and larger and larger. So if we look at it numerically, so if we were to plug into our calculators, I already plugged it in for you guys. Okay, so if we were to plug into our calculators, 1 over, here, let me type it in again, clear this. I'm going to clear. Alright, so if we type into our calculators, 1 over, and it's going to be 0.01 squared. Make sure that there are parentheses around the negative 0.01. So this is going to give us, what is that? 1, 2, 3, 4. So 10,000. So this is positive 10,000. If we look at 1 over negative 0.001 squared, this is going to give us 1, 2, 3, 4, 5, 6. So that's 1 million. So we have 1 million. If we were to go even further, divided by negative 0.000000001, it would give us, oops, I didn't square it. I'm going to go back up here. Let's square it. It's 1 to, or it's 10 to the 38th power. That's 1 with 38 zeros at the end of it. That's a huge number. So the numbers just keep getting bigger and bigger. The closer that we get to 0, the bigger the numbers get. Same thing happens on the positive side. So does f of x get closer to one number? The answer is no. Since the answer is no, it does not get closer to one number. It does not exist. So this does not exist either. Let's look at our last example, oscillating behavior. So with oscillating behavior, we have this one. This again is an example that does not exist. So we're looking at sine of 1 over x, and we're looking at the limit as x approaches 0. So let's see what happens when x is equal to 0. Well, when x is equal to 0, it's sine of 1 over 0, which is undefined. It has 0 in the denominator, which makes it undefined. So let's see what happens when x is close to 0. So when x is close to 0, again, we're going to estimate graphically. I have this graph in my graphing calculator. Let's graph this. So this graph looks really crazy. We could zoom it in a little bit more if you wanted to. See what happens here. It gets super crazy right here. Oh no. So it gets super crazy. So it does this weird, crazy stuff. But again, at 0, it is undefined. It's undefined at 0. So let's look here at, so let's look at what happens numerically. So numerically, what's happening? So we're going to plug in these values: 2 over pi, 2 over 3 pi, 2 over 5 pi, 2 over 7 pi, and see what happens. So I gave you guys the approximations just to kind of show you guys that it is in fact getting closer to 0. These numbers 0.6, 0.2, 0.1, 0.09. So they're getting closer and closer to 0. They're getting smaller. And but let's see what happens. So this right here 2 over pi. Since this is 1 over x, we're going to take the reciprocal of this and plug it into that sine function. So this is going to be sine of, instead of 2 over pi, it's going to be pi over 2. And sine of pi over 2, so let's recall your guys' trig. So sine gives you y values on the unit circle. And remember the unit circle, it starts at 0, pi by 2, pi, 3 pi by 2, 4 pi by 2, 5 pi by 2, and so on. So we're looking at pi by 2. Pi by 2 is right here. Our y value is 1. So that one's 1. At a sine of 3 pi by 2. So again, taking the reciprocal, because if we were to take the reciprocal of this, it would give us an x value. So we're going to take the reciprocal of this x value. It's pi of, or sine of 3 pi over 2. 3 pi over 2, there's 1 half, 2 halves, 3 halves pi. So this is negative 1. And we can keep on going. We can go 5 pi by 2. 1 half, 2 half, 3 half, 4 half, 5 half pi. That's at 1 again. So y is equal to 1 up here. We can go again. 1 half, so sine of 7 pi by 2. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. Sine of 7 pi, that's a y value down here, which is negative 1. So this would be negative 1. So as it approaches 0, well, does x get closer to 1 number? And the answer is no, it doesn't. It goes all crazy. So this answer is no, so therefore this one does not exist as well.